G'day there, everyone. I'm Nathan Lowe, and this talk is called Keep Your Sleep. Thank you very much for taking the time to watch this talk. I'm going to be covering database continuous integration and continuous delivery. And by the time you've seen these slides and gone through the code that I'll be sharing with you, you'll be able to make your database releases bulletproof and extremely useful. But first, some introductions. So on today's agenda, we'll be covering different types of database migration, making an Azure Devops build pipeline that uses Flyway to run migration scripts on the database in Azure, uses T-SQL-T to run some unit tests and report on those unit tests, and runs Schema Spy to generate database documentation. And while this is all happening, I'll be talking about this software that we're using and how it all works. And here's me. I'm an Australian living in Boston. I've worked with databases for over 10 years, and I'm usually the one pushing for Git and pull requests in most of the jobs I've had. I've got a GitHub out there with some useful code, a blog that I'll be updating with things I found out during the creation of this presentation, and you can reach me on Twitter after this if you have any questions. Also, something to note is that all the questions will be answered at the end, and all code will be made available on GitHub. Has anyone here ever had a release go so badly you have to roll everything back? Have you ever had to spend hours in the early hour of the morning trying to figure out what was broken and how to fix it? I know I have. And the nice thing about things these days is that you can use continuous integration and continuous delivery to make these sort of release nights not happen ever again. But before we go into too much detail, what is continuous integration and continuous delivery? I mean, you've heard it as a buzzword that's been used a lot these days. So let's try and just boil it down into some words that make a bit of sense. So continuous integration is basically integrating code that other people have worked on and yourself into a shared repository like Git or TFS or something like that, and then verifying all the changes actually do what they're meant to be doing with a build. Continuous delivery is then taking the artifacts from that build and releasing it to any environment, usually QA or production. And you're usually using like a main or master branch from Git in order to do so. Now we'll go over database releases. And I know I've said that. Hopefully not too many of you have to worry about a click ruining your day. So how does CICD apply to databases? Well, releasing a database is very different to releasing code. You have to be a lot more careful as you're basically working on an infinite state machine. So like a database can have infinite states because as soon as you make a change to a bit of data, now the database is in a different state. And since it's persistent data, it's a lot harder to roll things back if you've changed something. Like if you've deleted rows from a table in production, you're probably going to be a lot of trouble. If you've really deleted a column that doesn't need to be deleted, you're probably also going to be in a lot of trouble there. So CICD can include many things, but in this talk, I'll be covering database builds using Flyway, unit testing and reporting using T-SQL-T, and automated generation of documentation using Flyway. Schema Spy. So we talked about releases. Now it's time to talk about the different kinds of deployment you can use or the different kinds of releases you can use. The two main ones you'll see out there are state-based releases or migration-based releases. With state-based, you're going to describe how you want the database to look, and the tool will generate the code in order to get the database you're working on to match the state you've got in your source control. With migration-based, you create database change scripts, and your tool will just run them in the order you specify. So there's plenty of tools out there that can work with both of these types of release types. So state-based, has SQL Server data tools or Microsoft's, SSDT, which is pretty much Microsoft's gold standard for development and deployment of database code. You've also got Redgate SQL source control and Apex SQL source control, which is kind of a way of managing source control within SQL Server Management Studio. And there's many more out there. On the migration-based side, you've got Flyway, which I'll be talking in detail about today. You've got Liquibase, and you've got Squitch. I think Squitch doesn't really work with Microsoft databases that much. You've also got Redgate ReadyRoll, which is pretty similar to like Liquibase and Flyway in that it runs database scripts in a certain order and also generates them. So the nice things about these different database approaches are, with state-based, you don't have to write migration scripts, so that makes it a lot easier and faster to get releases out. There's also helpful tools out there for checking code in and ensuring that the database is buildable. You can, do a build with SQL Server data tools and just make sure stuff works. And with any of the source control tools with Flyway or Apex SQL, with Redgate or Apex SQL, you can just check stuff into Git within SQL Server Management Studio pretty easily. On the migration-based side, you can control what code is going to be run and know exactly what will be run, which is definitely reassuring on a release night. You also learn how to write repeatable database code, which is helpful for multiple things if you're writing a lot of stored procedures. The bad things about these ways of doing releases are, like with state-based, there is definitely a chance you can have slow or broken migration scripts that are generated, which is tough to happen to you on a release night. You also might change part of a database that you don't want to because someone's made a change in production and hasn't checked their code in. With migration-based, there's extra coding needed for repeatable code, and there's more onus on developers to ensure that their code would work. Like if you're trying to make a change to a column by making it not null, you're going to have to remember that you should probably put a default on there, or else there's going to be some issues with using that table in the future. Now it's time to go over the tools. So like I've been mentioning a few times, the tools that we'll be using today are Flyway, TSQLT, and Schema Spy. So Flyway is a pretty simple migration-based deployment tool that's free for the community version, which is nice. I also just like the tool because I've used it with both Oracle and SQL Server databases, so it's been helpful in the past. Now, there's no building you need to run, so you don't need to, join DAC packs together to make sure that it all works together. Everything's tracked within a Flyway schema history table, so it's going to track checksums on scripts and store procedures, and it's going to run anything that needs to be run automatically. You just give it a folder, and it runs everything that needs to run in that folder. So is everyone here sure their store procedures work the way they need to do? The nice thing about unit testing is that you can at least be pretty close to 100% sure after all the unit tests are written that everything is doing what it needs to do. And with the way that these tools are set up, it can set up your data, run your store procedure, assert that your test works, and roll back the whole transaction so that you're not making any changes to your database. It's all rolled back and everything goes back to the state it was in before the test started. There's plenty of tools out there for this sort of thing. You've got SQL Server data tools, which has its own way of doing unit tests. You've got TSQLT and Redgate SQL Test, which also uses TSQLT. So, for today, we'll be focusing on TSQLT. One of the nice things about TSQLT is that it can generate fake tables for you, and it loads them with data. You can also generate fake store procedures and just make sure that they will run and not have to worry about the results, and all sorts of other useful tools if you're trying to make sure that things are working and they're run. Okay, now on to database documentation. How many people here have a database that is documented fully? I don't think I've ever worked at a place where the database was all documented out or the database documentation was up to date. Wouldn't it be great if database documentation was basically just done for us every single time a build was done? I know that would make my life a lot easier. So here's Schema Spy. It's an open source Java program that generates HTML5 documentation for all your tables and their relationships with diagrams. It also finds some issues that you might need to fix in your database. So like foreign keys that need to be generated, indexes that might need to be made, that sort of thing. And now you know all the tools I'll be working with. I'm going to be using Flyway for the database builds and deployments, T-SQL-T for unit testing and reporting, and Schema Spy to generate documentation. So how is all these fancy tools going to be run? I'm going to be using Azure Devops, which uses YAML and works with Git repositories. And one of the really nice things about Azure DevOps is that it makes working with Docker containers much easier. You just put them in a resource list, and then you have them as your target, and it all just runs beautifully. The nice thing is it also runs PowerShell scripts in just about every other DevOps tool you're going to need. So it's really good for working with Azure environments because, well, it's basically built for Azure in mind. So now I've told you all about these fancy tools. What am I going to do now? Well, what I like to do is begin with the end in mind. So right now I'm going to show you like a demo and how things could be if you work with the sort of tools I'm showing. So here's a previous build I've done, but I'm going to run another build just to show you how it all works. And click on Run New. Start everything up. I've got a few variables all set up. Click on Run. Click in here to see what's going on. So this usually takes about a minute. So while this is all happening, I'll show the results of a previous run. So this is how your unit test can look. Like right now, I've got a passed unit test in here, and 100% things passing because I've got basically one test. And I've also got the artifacts generated from the previous build here. So I've got all the scripts needed to run to build a database, and I've got this database documentation here, which is just HTML5 all set up. Let's go back to the pipeline, see how it's going. So right now it's running the scripts to run the database and load it all up. Now it's running the T-SQL-T tests. Now it's publishing the results. Now it's publishing the whole database, all the artifacts needed to build it. Now it's doing the documentation creation. So there's where it starts. The part before is when it's pulling down a Docker container to run. It's made the documentation, and it's got all the files, and it publishes them. And then it's all done. Stops all the containers, puts it all away. So what would happen is you'd have all your artifacts here to be picked up, and you'd have like a test thing you can click on, like I can show you here. Click on that. I'll take you to all your tests. Click on this. You'll see all the documentation. So I'm going to show you a bit of the documentation as well. So the documentation, you'll see something like this. It's a pretty small database. There's not a whole lot to it, but you'll have all these different pages you can check out and the tables. So for right now, I'll show you the day rating table. You get all this information. You've also got a bit of commentary that comes out of the descriptions on the tables themselves. And then you get like a bit of it, like a diagram of the table itself. And then if there's any relationships or implied relationships, it's going to pick those up. And I think that's enough for now. So I can show you like what kind of things you can get set up. Now I want to show you how to basically set it up for yourselves. If you have any questions, please put them in as we're going through. And I'll try and answer them in the next demo, where I'm going to basically show the same thing but go into more detail. So first things first is you'll need an Azure account or the ability to set up databases in Azure. When you first set up, I think within the first year, you've got the ability to create free databases when you start. And an example database, the one I'm using, is about $5 a month. That's the smallest one you can get. I think it's like a basic one gig. So everything I'm doing here is going to focus on Azure builds. I mean, I'm sure it translates into like a local Docker use using Flyway. I'm sure that would work, but this is mostly on Azure. The next thing you're going to want to do is create a project in Azure Devops and set up payment for at least one Microsoft hosted pipe. Areas of interest are the repos section, like that's going to be where your code lives, the pipeline section where your builds and releases live. And make sure you've got some code in your repository. Like, I prefer to use Git repositories myself and pull requests just to make branching simpler and to make pull requests simpler as well. It's just nice to have a build work on a pull request and then make sure that's like a gate into making your code come into master or wherever it needs to go. So what we're trying to do first is set up Flyway. In this section, we'll be reviewing the folder structure for Flyway, how Flyway works, idempotent scripting, as getting Flyway to work on Azure DevOps with Docker and YAML. So for the Flyway code, I like to separate the code into different sections. One is initial setup, and then that is usually going to be like the most basic stuff you need to set up the database and you'll never want to touch again. So it could be, one script could be generating the database itself. The next kind of scripts could be like setting up roles and users and everything like that for what you need within that database. Maybe even some schemas. For repeatable, I'd like to keep like basically track of every single object you've got in this database, so you can track the changes made to that object made over time. Then you've got the sprint releases or just releases, depending on how you want to work with it, which is just going to be like version scripts for tables, views, anything that needs to be run in order. And then unit test is going to be like a folder with folders inside of classes and unit test for those classes. So I mentioned version scripts and repeatable scripts for Flyway. I think now's a good time to go over like what that means. So Flyway has two migration types. They've got a version migration and a repeatable migration. The way that Flyway works is it looks for all the migration files in a folder list that you give and then runs them in the order according to migration type. And I'll go into that in more detail in the next slides. So here's the two migration or file types. You've got the version, which needs to start with capital V, then like the number order you're running it in, and then 2 underscores. And this will run before any repeatable scripts are run in numerical order. So you can have like 1, 2, 3, 3.1, 3.1.1, and then 4.12. And it's going to run in like the order that the numbers go in order. Repeatable scripts all start with R underscore underscore, and that will run after all the version scripts have run that need to run. And these are the way you like need to name these files. Like I was saying, like versions, you're going to have V, the number you're putting in. You can put dots in. That works fine with Flyway. But you need to make sure you've got your double underscores in, or else the file won't be picked up. And then what I like to do is I put like the story name or the ticket number in as like at the beginning, and then I try to write like what that store procedure or this script is doing. Like in this case, it's creating a test procedure in the DBO schema. The repeatable ones are a bit easier to do, but what I like to do is, you've got to have your R underscore underscore at the top, at the beginning, but you also need to, like I like to put in the schema name, the object name, and then the type of object it is, so like table, store procedure, function, that sort of thing. And with these version numbers, I like to put in like 100, 200, 300 as the version numbers in case something happens and you need to put something in between. Like let's say you need to put something in between 100 and 200, you can put it at 150, and that's going to work in the right order. And you can also set up Flyway to like run out of order too. So it's going to like pick up stuff that is put in between things. Okay, one other thing to keep in mind with these two different file names is that the story and the history of all these like files that are used. With versions, it's going to store like the name of the file and if it was successful or not, and it's going to score a checksum. So whenever Flyway is run again and the file is changed, it's going to error out and say the file was changed and ask why. Or if the file itself is missing, then the build itself will break. So it's going to be like, why did someone remove this file? It's part of the versions, like it needs to exist. Then on the repeatable side, it's going to store a checksum along with like the file name and everything. But if the file itself is changed, the file is run against the database to make sure like it needs to be run again. So like if you got a checksum in the database, it's the same as like a previous version of the file, and you run the script again after changing it, the checksum in the database is going to need to update. So it'll run it once, have one checksum, change the file, run Flyway again. It's going to run the file again and then update the checksum. If the file is renamed or removed, you're going to have to run a repair on the database to make sure the file is marked as deleted, or else the build will fail. So this Flyway history table I keep talking about is called Flyway_schema_history. So this table stores checksums, file names, and version numbers, and if the file runs successfully. You'll be looking at this table a lot if people like change files that shouldn't have been changed or delete files. I mean, the nice thing about Git is that you can back a lot of that stuff back up, so it doesn't have to happen. And then you can also just change the checksums in the table itself to make everything work. I think the Flyway repair will also do a lot of that for you as well. So these file types are best for, with versions, you basically need anything where order matters, right? So any changes to a table, any security changes, or any views that depend on other views. Now you're going to have to write those out to run in the correct order. And repeatable, anything where an order doesn't matter. So in most cases, stored procedures are going to be okay running if it's missing out on objects or anything. It just gives you a note that says, oh, you're going to need this. With user-defined functions, it's going to be okay sometimes, but if it's looking for like a table that doesn't exist, you'll need to make sure it's in a version script. And then synonyms, they just kind of work, but they won't tell you if the synonym actually exists or not. Now it's time to go over database file structure. So with these versioned files in the sprint releases folder, is basically just like a bunch of folders for the sprints or the release that you're in. And you put all the files needed for that release into that folder. And the nice thing is that due to all the naming set up, like the way you need to name the files, they'll always be in the right order. So it's pretty nice to go through. And if you've got like small sprints, like every 2 weeks, it makes it a bit easier to kind of work through. With a repeatable folder structure, I generally like to work with like the same, like within the same structure that the generate and publish scripts user interface uses. Like every object should have its own file within like a tables folder or a views folder or a store procedures folder. And once you've done all that, it's pretty easy to like follow things over time. And it also makes it easy to like work within a database that you're that already exists. You know, you generate all your generate all your scripts, and you put them all into like their own like object type folder. So like all the tables can be generated and put into a tables folder. All the views can be generated and put into a views folder. That sort of thing. Now we're going to go over when to use the different types of scripts. So I like to use repeatable scripts when the order you change, like you make your change, doesn't matter, or it can go after any version changes. So, if you've got a store procedure that can just get released after everything else, you can put that in a repeatable release. It doesn't really matter when it comes out. It can be like the last thing to be released after everything is released. That's when you'd want to use a repeatable script. But in most cases, you're going to want to use both. So if the order your change is released matters, then you have to add a version release and update, add a repeatable release script as well. This way you can see changes to tables, views, and everything over time, and you control the order the code runs in. Idempotent code. So how do you make your code idempotent? I mean, with this sort of stuff, you're basically trying to make sure that you can run it over and over and over and over again, and nothing bad happens or it doesn't break. The nice thing is when you're using creator alters for the objects where you can use them, that just does that for you. You can use them for views, you can use them for functions, you can use them for stored procedures. But when it comes to things like tables or columns, you can't really do that sort of thing. So you have to try using like is exists or is not exist to see if the object you're going to be adding or removing already exists. So you're going to be using it on tables, foreign keys. You can even use it on data loads when you're like trying to insert data. You can always like look for the first row that should have been inserted, and if it has, then don't add anything else. But in this example we've got here, I'm trying to add a column. So I'm checking to see if the column doesn't exist. And if it doesn't exist, create this column here. The nice thing is like, if you've got all your scripts set up this way, you can run Flyway again and again. Like you can truncate the history table and rerun everything. And hopefully it'll work. I mean, in most cases it will, if you've got the script set up correctly. Okay, so here's the commands with Flyway. You've got migrate, which is what you'll be using most of the time. You've got clean, which then just drops everything in the database. So please never ever use that unless you've got a really good reason. You've got info, which is like migrate, except it's not going to run anything. It's just going to tell you what's going to be run. You've got validate, which looks at your files and validates them against that history table I was talking about. You've got baseline, which can baseline an existing database. And you've got repair, which I think I've been mentioning a few times, is what you might want to use when you've got tables where the checksum is different to files you've got, or you can just make the changes yourself in the database. Setting up Flyway on Azure Devops. So this is where most of the work we'll be doing goes. Now I have to go into Docker containers as well. So what is a Flyway Docker container? So pretty much this is a Docker container that has Flyway installed on it and ready to go. So it's a really nice thing to set up and put within your builds, because you don't need to install Flyway on a build machine. You don't need to install like Flyway in your Git repo, which is something I've had to do. And you can always have the latest version of Flyway ready to go and be downloaded, like as it's downloaded or as new on every single build that you're running. So it's just kind of peace of mind knowing that you've got like the best version of Flyway ready to go whenever you need it. And I'll go over some YAML code in this as well. So YAML is the latest language that Azure DevOps uses for its build pipelines, which stands for yet another markup language. You're pretty much marking up how you want your build to run. Today I'm going to be focusing on the resources section and the jobs section. So when you're setting up like your containers and your resources, it's not that hard, which is nice. You've just got a couple of lines of YAML to write. You write out like the resources section, you're writing out containers, then you write the name of the container, which in this case is just called Flyway with a little f, and you write out the image of the container you're looking for. So I'm looking for the Flyway Azure image and the latest Alpine version. So with Azure DevOps, you need to make sure you're using the Flyway Azure container, because otherwise it won't work. And then that container itself needs the Alpine version in order to work. So when you're writing out jobs and steps, you read to, most of the time you're going to need to write the jobs section. So you need to write jobs out. You need to give the job a name. You need to give the job a timeout in minutes amount. And you need to write like the VM or the pool you want it to run on. So you can have multiple VMs, but in this case, I'm just going with one Ubuntu 16.4 image. And then you write steps to get the steps section started. And the big first step is a doozy. There's a fair bit in there, but I'll go through it now. So One of the main things to look for is like the target we're running it on. Like this can either be host or the name of a container you're running on. So since we've got the Flyway container, we'll call it Flyway. So that's going to be our target. Then we give it a name called run Flyway migrate. And we have all the steps to run the Flyway in here. So we've got the OL, so the JDBC connection string, then some usernames and passwords, which is easy enough. And then these locations is the locations that Flyway needs to look at to find all the files it needs to run. In this case, we've gone pretty easy and just said like the current directory wherever you're in is where it needs to start looking. And then it looks for all of the children in all the directories and all the children as well. And then use Flyway migrate. And that's pretty much how to run Flyway with the scripting. And here's the results of like how it would look. So you can see that like Flyway is running on the container. It's looking at the database, which I've given. And it's all been successful. So that's great. Let's move on to the next step. Now it's time for T-SQL-T. With this, I'll tell you how to run your tests, the PowerShell scripts needed to run these tests, and the YAML code needed to run the PowerShell scripts and publish the results, and then some example results. So, I think unit testing is very important and needs to be done and is really helpful for all your databases. It's just I don't really have the time within this talk to go over unit testing itself. I'm just going to be going over publishing the results of your unit tests and making sure that everything runs. So when you've got T-SQL-T set up on your own database, you want to have some test classes and some tests in T-SQL-T. You can then use T-SQL-T run all to run all the tests, and use T-SQL-T XML result formatter to format these results as XML. Then YAML can pick that XML form and put it on a nice pretty website for you. So here's the PowerShell script, which looks pretty daunting and pretty big, but there's only really two areas that you're pretty much interested in right now, and I'll go through those now. Okay, so you've got the SQL command here, and this is where it's running the SQL. Everything else is just kind of getting connection strings, getting the command, getting some data sets and some adapters and putting all that together. But here's what we're trying to run. So we're doing the whole T-SQL-T run all, and then when that's done, do the XML resort formatter. That's it. It also puts it into the JUnit XML to be picked up by Azure Devops, which is nice. Okay, when that's all done, you've got your data set, and PowerShell is basically putting out the data set into a XML file called test-tsqlt.xml. You'll need to remember you've got this text test in the file name because that's what it's going to be looking for when it's doing the export and the pushing out of publishing of the test results. So setting up T-SQL-T on Azure Devops. Water time. It's always a good time. All right. So what we're doing here is running PowerShell and publishing test results. The PowerShell stuff is kind of pretty boiler textbook way of running PowerShell. I'm saying there's a host here, so it needs to run on that VM, like I was saying previously. I'm giving the step the name run T-SQL-T tests, and then I'm running that PowerShell script I'm showing you while passing some arguments to it. And that's it for the PowerShell. Then for the published test results, I'm trying to run it on the host again, and I'm picking up anything that has the test dash in it, because that's just the way to pick up some unit tests. And then you get that whole website I was showing you before when it's all done. So it's a nice quick way and a quick win to show you can make unit tests happen. I think the hard part is making all the unit tests. All right, last thing to go through is the Schema Spy Setup. So we're going to be reviewing the documentation it generates, using YAML, Docker, and Schema Spy to generate documentation to be published, and the YAML code to basically run the PowerShell and publish the results. So Schema Spy works with a few sections. You've got tables and views, columns, constraints, relationships, orphan tables, anomalies, and routines. So those are the different pages it can generate things for. Like I was saying, like there's an example of like some documentation with a day rating. So you've got your column, you've got your type, size, whether it can be null or not, which is marked by a check, and then a default. Children are like any tables it connects to, and parents are any tables that like connect to it, where the other table has is kind of the parent in that relationship. And then comments, so like I was saying, like any descriptions or anything about those columns. Now, one of the pages, like I was saying, was the Orphans Table page, and on here you'll have like any tables that have any relationships to any other tables. So, within the database I've got set up, none of them do. Basically, just to show like this is how they'd look on the documentation. And then the anomalies I was mentioning before, you've got like things that might be wrong with the database that you should have a look at, like tables without indexes or tables whose name and type imply like they could be related. So like user ID could be in both of those columns, like in both of those is in both of those tables. So maybe there's a relationship there. Tables that contain a single column, or tables with like incrementing column names, so like question 1, question 2, question 3, which might be better off as like its own table and be normalized. And how to get text into Schema Spy. So you remember the comments I was having here? Let's show you how to make that happen automatically. So one of the nice things is this is a description extended property within every single column and I think every single table of SQL Server. If you fill those in, then you'll see them come through as a comment in the documentation. So theoretically, you could be entering these descriptions as you enter things into a table, and then it's already going to just generate documentation for you. You don't even need to worry about it. Setting up Schema Spy on Azure Devops. So this section here is pretty much a multi-line Linux script that's going to be creating a output folder using mkdir, then giving this whole process that I'm running now like permission to change that folder using the change mod and then 777, and then run Schema Spy from a Docker it's downloading. So when you're running Schema Spy in this way, you need to set up some external mounts with the V flag. So you'll see here I've mounted the output folder that just got created to output that's inside the Docker. And then I have another driver, my DB driver folder, that has the JDBC connection driver that I need for SQL Server. And it gets picked up and put into a drivers folder within the Docker container. So here's the stuff you need to do when you're trying to run Schema Spy from a Docker container. So you're mentioning the whole Schema Spy Docker container here. So I'm using the latest one. Then I'm trying to use the MS SQL 08 driver, which I've got inside the drivers folder. Then there's a database name, a server name, port number, user and password, which is all used to basically generate all of your documentation. So it's connecting and running and then putting it into an output folder to then be picked up from the outside of the Docker. And then when that output folder is generated, then I'm publishing it by using this whole system working directory output database documentation. You also give it a artifact name, and then it all just gets published for you. So here's where it's publishing the artifact. And then here's like how it would look for your artifacts, like results. And then that's it. So now you know what I'm talking about. I'm going to review the demo again and see if I can answer some of your questions this time around. Let's try this demo again. This time I'll show you the actual code itself. So we'll go back to the code. So you'll see inside here, I've got where I'm creating the Docker containers. So I've got like a Flyway one and a Schema Spy one, but I don't think this one ever gets used since it's being run down here. Then I've got the whole job steps I'm talking about. So we've got the job creation, and then here's the steps running. So one step is that Flyway script that we went through. Another step is the task that we went through. This is running all the T-SQL-T tests. Then we're publishing all the T-SQL-T tests. Then we're publishing the database itself. And then I'm running all the Schema Spy code, and then publishing the output. I mean, the interesting thing about this whole YAML thing is that you can also use a whole bunch of tasks that are generated over here. And there's a lot of tasks to go through. Like, I think this would be a talk in itself, trying to go through all of the tasks that they have that you could put into YAML in here. I'll just add like one just to show you. Okay, we'll just like add that. But you could type in whatever. And it adds things for you. Like, it makes it really easy to add steps to a YAML script, which is nice. I just won't save anything. And we'll run it again. So you'll see it here. Go into the example database build. See if I can show a bit more of it this time. So you'll see, I think the variable stuff's pretty interesting, which I'll go back to. So these are variables that I was putting into every single step. It's just really helpful to have. You can even make like private variables too. So that, like, I think I've got username and password in here as private variables. And it's going to download all the containers needed. This is downloading all the script, like the Git code, which is usually pretty quick. This time around, since I've already run it once, there's no migrations to be made. So it's just going to say run Flyway, but no migration necessary. The test will still run. I'm going to publish the artifacts, and you can see like a different version of the tests. If you click on the link here, it gives you like the test plans, and if you had more tests, more like documentation on them and the results. Then it's going to be publishing the website here. Not the website, sorry, publishing all the scripts from the database. It's going to run Schema Spy. So here you can see it like downloading the Docker image. Then it's going to run your Schema Spy, and it does everything. Then you'll see the artifact. Then we'll have everything there, and that just stops all the containers. And then, yet again, we're done. You finalize the job, report the build status, go up here. It's all looking good. And I think everything else I've pretty much shown you before. So I don't think I've seen any questions either. So I think that's pretty much good for a demo. So thank you very much all for your time. In this talk, you've been given a quick introduction to Flyway, Schema Spy, T-SQL-T, Azure Devops, and YAML. And if you're ever interested, You can check out the GitHub. I put that link if you want to review the code. It should be all up there now, which is good, and I'll make any changes if they're needed.
Yeah!